We're going to discuss conditional probability. How it's described is, the more official thing would be that we're going to be talking about independent and dependent events. So it's the probability and in situations that may depend on other stuff. First, we have to talk about what is independent versus a dependent event. So if you have two events, they're independent if the probability of one has no effect on the probability of the other. So for example, let's look at A. If you roll a die and then roll it again, and let's say you're looking for 4s or something like that, what you roll, the probabilities on the second die don't depend on the first die. What you do over here has no effect on the probabilities over here. So these two events, rolling the die and rolling it again, would be independent. If you roll a die and pick a card from a full deck of cards, rolling the die has no effect on which card you pick from a full deck of cards. Also, so these two events are independent of each other. If you pick a card and pick another card, well, for example, let's say we're looking to pick hearts and we want to pick a heart and then pick another heart. Then whether we pick a heart on the second one depends on whether we pick the heart on the first one, because that's going to make fewer hearts available. So the probabilities for the second card depend a bit on the first card. So these are dependent events. They affect each other. You pick a car, see if the brakes work. Cars are not all the same. So for example, maybe if you pick a Chrysler, it's more likely that the brakes are not going to work. If you pick a Mazda, then perhaps the brakes are more likely to work. So these two events are dependent on each other. There is a formula. If A and B are independent events, so if these events do not affect each other's probability, then the probability of A and B is just going to be the probability of A times the probability of B. But that's only true for independent events, for events that don't affect each other. Okay, so let's do an example. What is the probability of rolling a 4 twice when rolling a 6-sided die twice? So we have two events here. So the two events are A, we want to roll a 4, and we want to roll a 4 again. And then what we know is we know that the probability of rolling a 4 is 1 out of 6. And the probability of rolling a 4 again is going to be also 1 out of 6. So the probability of rolling a 4 twice is just going to be the probability of the first one times the probability of the second one, which is 1 over 6 times 1 over 6, which is 1 over 36. Which we kind of already knew. The probability of rolling double 4s, if you roll 2 dice, is 1 out of 36. 36 options. Oops. Okay, you might want to pause this and write it out. So there's a 70% probability that Sarah will see David, and a 40% probability that she has gum in her pocket. And so the two questions are, what is the probability that Sarah sees David? And what is the probability that, what's the probability that Sarah sees David and has gum? What's the probability that she sees David but does not have gum? Okay, so let's do A first. We're going to define some events here. So we're going to say that event A is that she sees David, a lucky circumstance. And event B is going to be that she has gum, also a fortuitous circumstance. There's some probabilities associated with these things. So the probability of seeing David is, from the question, 70%. And the probability of having gum, from the question, is 40%. And there's no reason to believe that one has any effect on the other. If she sees David, she's not more or less likely to have gum in her pocket. They're two independent events. We're also going to mention in this case that the probability of not A, so in this case the probability of not seeing David, if there's a 70% chance of seeing David, then there's a 30% chance of not seeing David. Similarly, the probability of not having gum is going to be 60%. So, putting all that together, what's the probability that Sarah sees David and has gum? So what A is asking for, I guess now we're actually doing A. That was kind of like our setup. So what is A asking for? A is asking for the probability of seeing David and having gum, which is going to be the probability of seeing David times the probability of being gum, because they're independent, which is going to be 0.7 times 0.4, which is 28%. Now what B is asking for, sees David but does not have gum. So we want the probability of seeing David, and we want to see David and not have gum. Probability of seeing David, that's just going to be the probability of seeing David times the probability of not having gum, which is going to be, probability of David is 0.7, and the probability of not having gum is 0.6, which if you multiply them, turns out to be 42%.